Okay, so hi everyone. I'm going to start with the introduction. I'm Dimitri, in case you don't know me, but I think everyone does. I did my project, I had the privilege of doing my project with Wavelength Law, which corresponds to my background, which is more in compliance, which is kind of legal, but not really. It is very similar to this, a lot of reading text, a lot of understanding what it means, and a lot of rule extraction. But in here, not in there. So, this time the project, also one of the reasons why I started the bootcamp was to actually understand how one could automate a process like this. And this was exactly what happened. So the topic is rule, aka logic, aka concept, aka information extraction. If you want to ever Google any background on this, that's what you put in there. We have, everyone knows NLP, everyone knows Spacey, so we have, first of all, entity identification. This is basically a statistical task. This is looking at a word and saying, this is probably a noun, and this is probably a certain type of entity. Spacey has its own named entity classifier. It recognizes locations, it recognizes people, currency, numbers, cardinals, you name it. However, during this task, I had to retrain the entity recognizer to our custom needs. So, the next step would be building relations, establishing relations between these entities. This is the second rule. This is the second step. Why? Because in order to extract information, you, for instance, English is an SVO language. That means subject, verb, object. That means something is and the object. So, the is the relation. So we have to understand how each entity relates to each other. And the third is understanding. This is already going into the realm of artificial intelligence, unlike the previous two steps. This is not based on statistical methods. This is actually building logic, extracting logic out of what we have, out of the entities and their relations. So that's why one of them is logic extraction. We have an example of this. One of the best documented examples that I found online was RELX, similar to regex, rel for relation. So what it does is basically, what it did was they had a huge data set of biomedical documents, and they wanted to find out how each protein relates to the other within the human organism. And you can see the workflow there. You have sentences, then you have the different types of parsers. You can see noun phrases, named entity, which I mentioned already. Noun phrases are pretty simple. It's basically the noun and all the adjectives that apply to it, or other modifiers. So it's like it's taken as a single token. Spacey has this functionality. I did not use it, but you could implement it. I did not use it for better measures, basically. So, as said, you parse. You build the relations, and then you do, you can't really read that. You do negation check, you do enumeration, resolution, restriction. This is the AI layer, basically. So filtering the logic out of those relations. Right, so let's take a look at the task. I was raving about how compliance and taking information out of text. Here is basically the example. We had two tasks. First task was structured data, extracting address, title, and doc ID from a prescribed format. This was basically, well, I'll tell you about it in the approach. Second task was extracting correspondence with predefined rules and data artifacts. Data artifacts were such as working hours and days per week, number of holidays including or excluding public holidays, terms of holiday allocation, for instance, working during public holidays, and terms of holiday pay. When is it paid, or whether it's paid, and how it's paid. So you can't really see the text below, or can you? I don't know. Can you read it? I'll just read it for you. There were two chunks of text, so to speak. The first bit, that was with the working hours and days per week, and the second bit was about holiday allocation. So the first bit, your normal working hours are 8:45 to 5:45 on 3 days a week with breaks and a 1 hour lunch. Geez, I'd love to have working hours like that and get paid the same as I do. You are entitled to 26 days holiday, including bank holidays, during each holiday year, calculated on a pro rata basis, referenced to a full-time entitlement of 35 days holiday each year, and the usual 8 public holidays in England and Wales. Public holidays which fall during term time are normal working days. You may be required to work during public holidays. Oh God, okay, no, I don't want that contract. And including the August bank holiday, definitely don't want it. You will be entitled to a day in lieu when we require you to work on a public holiday. Okay, maybe. And you will be paid your normal basic remuneration during such holidays. Now, that's a lot of text. That's a lot of expressions, and it's also expressed in a different way. This is just one example of the data. It was not like this. I mean, some of them said you will be working from 9 a.m. to 7 p.m. on Monday, then from 10 a.m. to 3 p.m. on a Tuesday, and so on and so forth. You can imagine the variations. As well, the entitled to 26 days holiday, some of them did not mention pro rata calculation, some of them did, some of them said including public holidays, others just said in a different sentence that in addition you are allowed to have 8 public holidays, and so on and so forth. So there's quite a bit of syntactic variation. However, the semantics are more or less the same, and this is exactly what we're trying to extract out of the text. So, our approach. Task 1, simple regex statements as data was structured, and I thought, geez, I'll finish the rest by tomorrow. Little did I know. Task 2, use regex to clean data input. This was, again, more or less the same. This was taking out spelling mistakes, taking out like zeros, where O's, which were supposed to be zeros, I's, which were supposed to be ones, and so on and so forth. I mean, if I had a bit more time to research, I guess I would have taken a Python module that did spelling correction. However, because the data was all the clauses, they're expressed in a similar way. This is the good thing about legal text. There's a lot of sentences that repeat themselves. And hence, I was able to use a few basic tricks to basically clean the data and get a very good accuracy out of it. So, then, use matcher to find entities of interest. First of all, this was one of the bigger tasks. This was marking these marking entities. Spacy has a thing called a matcher, which basically takes, you can specify phrases in a regex-like fashion. It will match them, it will mark them, and then you feed that to the entity recognizer. Train, export. So, before training, it's hard to see here, but it says cardinal, normal working hours are time, 8:45 to 5:45 is time. After training, we recognize time, days per week, lunch, public holiday, entitled, and holiday entitlement in days, and the rest are public holiday. So, as you can see, the training is completely different. After training, the recognizer is completely different. Task 2 was build the whole logic behind it. I say I'm running out of time, so I'm going to start running through. So, this is where I built that custom function that I was raving about, scan_send. It basically takes the parse tree, runs down the parse tree, finds what it needs, runs back up, and finds what the other part of the sentence. So, subject, verb, object, as you remember. If it's there. If it's not there, it returns nothing. So, it basically returns everything that applies to that phrase that you're looking for. Then convert the values in accordance with the spec and export the results. This is a parse of a sentence. I will quickly show you a live version of it. So this is the sentence. Yep, this is the beginning of the sentence. Everything coming out is, unfortunately, I also noticed that it's not HD, but you can see this is root. So those are the main phrases inside the sentence, and these all express different chunks of data. So this, for instance, talks about working hours. Your normal working hours are 9 to 5, 3 days per week, 1 hour lunch break. So the algorithm, what it does, you specify, for instance, you want the verb be, the lemma of the verb to be, so is. You specify, I want to know about lunch. So you either specify the entity, you can see colored ones are the ones which it recognizes as named entities, as time, lunch again, and days per week. Find that entity and find the other bit of the other bits of the sentence that applies to it, if there is one. In this case, you would just specify be and lunch, because you just want to find lunch. So it just goes down the tree, takes this bit, and goes back up without taking anything. Right, and back to the presentation. If you want, I can talk a bit more about it afterwards. Right, so That is the complete parse tree. In some cases it does work, in some cases it doesn't. It's the standard IT question. It works, why? It doesn't work, why? And I noticed that all my errors were coming from the fact that the dependency tree was being parsed incorrectly because Spatie does not really handle big sentences well. So one of the improvements to this model would be, and I mean, I already have ideas on how to implement it, I just haven't had the time, is to make Spatie look at separate phrases separately, and then link them to what it applies to. For instance, your holiday entitlement is 26 days, in brackets, calculated on a pro rata basis. This calculated on a pro rata basis applies to the 26 days holiday. So that's what you would do. You would basically write an algorithm that reads that, finds brackets, chunks that sentence, takes the root of that phrase, and puts all the dependencies back to where it's supposed to. That's it. I mean, simple fix. You'd think, but there's quite a lot of coding behind it. Yeah. So evaluation. Again, standard. You have check the results, compare them, check entity matcher, adjust extraction calculation algorithms, find data entry errors which were present, and repeat. So with this, for instance, in the training set, the unmatched entities actually helped me find data errors in the manually marked set. So test the model on the full data set after you're happy, and as we said, after the evaluation, most common problems were due to the parse tree, dependency tree not being parsed correctly. A couple of errors due to incorrectly matched entities. Again, this is a statistical method, which it does give errors sometimes, but as long as it's accurate enough, you're happy. If it's 100%, you're usually actually not happy because that means it's probably overfitting. And also taking into account the fact that the whole data set, the training data set was 79 entries, and the full data set was 114, overmatching is a very likely issue because it's such a small data set. There was one case where the sequence processing is required, so you need to, one phrase, and then you need to see what the next phrase applies to, so that you can add that logic, so you can read that logic as well inside that paradigm. Basically, it's a lot of ticking boxes and then seeing how it ticks back. Right, and it's alive. It is indeed, you ask it a question and it gives you an answer. It reads the parse tree and it returns a value. The results, why do I say it's alive, was on the training data set, 79 entries, it said 15 rows with errors. I had to extract 12 features out of the data, so 12 pieces of data. And this is 15 rows with one error in them. So across the 12 features. 81% absolute accuracy. If you take individual features, an average of 2.3 errors per feature, a maximum of 7 errors, recall of 97%, precision 91, and F1 of 95. I think that's pretty accurate for a first try, so to speak. On the full data set, so that's testing and training plus testing, we had 21 rows, 83% absolute accuracy, and you can see the values are very similar. That means that the model is working as it should, basically. And it just needs some tweaking. Yep, conclusion, further research into this would be analyzing, writing text, legal text, because it is expressed in a very deterministic fashion. It's basically a model, either a framework, we call it a legal framework, or a legal process, for instance. You go from point A to B, fulfilling certain requirements. Each entity goes through per process. More training is needed. Spaces dependency parser needs improving. Chunking sentences, like for instance things in brackets. Plus, Spatie actually has a GUI for training the dependency parser. I would have used it had it not cost $500. So basically, Spatie is free and it's fantastic as a tool. It's very versatile. It's the Swiss Army knife for NLP. It may not be good for big data sets or big sentences, but as Keita, I think, mentioned, if the data breaks your algorithm, break the data, and it will be okay. again, this can pave the way for information extraction algorithms from unstructured text. You can find conflicting relations, for instance, two contracts or two processes, whether they have any conflicting points. Future development in this field, of course, entity extraction and relation categorization. I mean, you can use, again, machine learning models to say, for instance, calculated is similar to derived. Yep. So you say, you ask, how is this calculated? And if in the contract it says the value is derived, it will find it by a similarity vector. And yes, that's it. Yep. Paving the way for smart contracts.